Okay, so I wanted to make a follow-up video for problem 3, the very first problem, just to make some clarifications, okay? So clarification number 1, it's key that they say f is differentiable at x equals 2. And let's remember what that means. This function, this is a function of, up here, this is a function of x, but it's not differentiable at at x equals 2. It's not differentiable at f equals 2. It does have, it actually has two limits at 2, and that's the problem. This is a discontinuous function. It's got one limit at 2 as you approach 2 from positive infinity. There's one limit at x equals 2. It's got a completely different limit as you approach 2 from negative infinity. So it is a function, but the problem, it's not differentiable because it doesn't have a single limit at x equals 2. This is a differentiable function. In other words, this is continuous at 2. This one up here is not continuous at 2. So, but once you know that this is continuous, then you can say, using the standard notation, the limit of h, the limit as h approaches 0 from positive infinity of f of x plus h minus f of x over h, that limit is the same as the limit as h approaches 0 from negative infinity. And that's why you know that one answer where it gives you this expression, you can say it's equivalent to the other true expressions. Now, clarification number 2. I think at one point, let me erase this positive sign. I think this is answer C. This is answer C. This represents the limit. Oh no, this is just the general expression for the derivative. And in fact, this you can use to calculate the derivative. But notice, if I substitute 2 here, this now represents f prime of 2. However, I think I said you can use this formula to calculate the derivative at 2, and that's not correct. This is, you could say this is the definition of f prime at 2, or you could say this expression represents the derivative at 2 when x equals 2, but you can't calculate the derivative at 2 from here. You have to go back and either use the shortcuts. Again, if let's say f of x equals x squared, you have to use the more general formula using limits to arrive at f prime of x. Or you can just use the shortcut because it gives you the same answer. We just know that equals 2x. It's only then that you can plug in 2, and you would discover that f prime of x when x equals 2, or x equals 2, that equals 4. Okay, so just a clarification. And finally, clarification number 3. Let me go to a new page. We had this, I made this big speech about this way of representing f prime of 2. I made this big speech saying if x approaches 2 from positive infinity, this will be plus and this will be plus, positive and positive. There's an assumption there. That assumes, of course, that as x increases, f of x increases. But of course, that's not always going to be the case. But let's, if we make this assumption, what I said is true. If we assume this, then as x approaches 2 from positive infinity, this will be positive, will be positive. If x approaches 2 from negative infinity, this will be negative, this will be negative. And if you're going to start reversing the signs, if you're going to reverse the sign in the numerator, you have to reverse the sign in the denominator as well in order to have an equivalent expression. It doesn't matter, of course, if as x increases, f of x goes down, the general statement is still the same. It's just that f of x minus f of 2 is going to be negative as x approaches 2 from positive infinity, and the denominator is going to be positive. And as x approaches 2 from negative infinity, in this case, then the numerator is going to be positive, but the denominator is going to be negative. So the point is, again, it gets back to the idea that the limit doesn't matter whether you come from positive or negative infinity. The sign of the limit, of course, depends on which of these is true. But the general point is still the same. If you want an equivalent expression, you have to change the sign of all terms. So you change the sign of this term, this becomes f2 minus, you have to change the sign of this term, so that becomes f2 minus fx. But you also have to change the sign of these two terms, and this would become 2 minus x. But this would be an equivalent expression. End of clarifications.